What you are looking at is a massive circular feature within Mauritania. It is a truly beautiful geologic oddity largely only visible from satellite. Known as the Eye of the Sahara, it is a spectacular 45-kilometer or 28-mile wide feature which contrasts with the overall coloration of the surrounding sandy desert landscape. We didn't know that this massive feature even existed until we sent humans into space, where they specifically searched for massive circular structures on the planet in the hope of finding previously undiscovered impact craters. However, this massive feature is not an impact crater. Although this geologic oddity does contain numerous concentric rings, it has a different origin which is partially related to magma. This video will discuss the spectacular feature and describe how it formed. The Eye of the Sahara can be found in west-central Mauritania in Africa, where it is not too far from the border with Western Sahara. Specifically, it is 190 kilometers east-northeast of the city of Atar. The Eye of the Sahara began forming 201 million years ago when the supercontinent Pangaea, which comprised most of modern-day Africa, North and South America, and Europe, began to break apart. This slow breakup began due in part to a massive mantle plume of material which was around 20% hotter in the mantle than surrounding rock. As it intruded into the crust, numerous flood basalt eruptions occurred over a vast area, creating large outpourings of lava on the order of hundreds to thousands of cubic kilometers of rock in each eruption across an area ranging from Newfoundland to Spain to Brazil to Mauritania and beyond. In Mauritania, two such intrusions would occur which would fail to reach the surface, expanding out horizontally to form two-layered sills which contain volumes of 12.4 and 5.3 cubic kilometers of magma respectively. This surprisingly did not notably uplift the overlying rock, instead largely replacing pre-existing rock units. By 115 million years ago, while North America had long ago separated from what was originally Pangaea, West Africa and parts of Central Africa remained connected to Eastern South America. Then, finally, these two continents began to spread apart, occurring alongside the formation of a major rifting event in Western Africa that would go on to form the Cameroon Line. As the crust rifted apart over the next 14 million years, large faults and weak points in the crust that trended to the north-northeast or simply northeast formed, allowing for hot mantle material to intrude into the crust at these weak spots. These rift settings soon were the site of abundant phonolite or high-alkali magmatic intrusions. One such intrusion occurred underneath what would eventually become the Eye of the Sahara 101 million years ago. As this large body of magma built up in the deep crust, a threshold was eventually reached, causing a large portion of the Phonolite Magma's carbon dioxide and alkali elements to separate and form a separate magma type known as carbonatite. Approximately 50 cubic kilometers of carbonatite magma then rose upwards towards the surface. Reaching shallow depths of about 1 kilometer, this massive body of molten rock pushed upwards 1,800 square kilometers of rock by as much as 305 meters or 1,001 feet to form a structure known as a dome anticline. A series of kimberlite magmas intruded into the vicinity over the next 1 million years as the carbonatite magma cooled, emplacing a cluster of small dikes. Across the next 100 million years, the uplifted rock was eroded at a higher rate than its lower elevation counterparts, leading to numerous layers of sedimentary and igneous rocks being exposed in the magnificent Eye of the Sahara. An interesting quirk of the Eye of the Sahara is that the oldest rocks are found in its center, while the youngest rocks are found near its edge. Overall, more than 1.2 billion years of geologic history is exposed in this vast feature. Although best visible via satellite or an airplane, it can be visited via a number of remote dirt roads.